Hello guys, in this video we are going to discuss the solution of a problem form of palindrome. So let us look at the problem statement. The problem statement says, given a string, find the minimum number of characters to be inserted to convert it to a palindrome. So for instance, if this is the string which is given to us, in order to convert this string to palindrome, we need to add dcb towards the beginning of this string in order to make this entire string a palindrome string. And since we are adding 3 characters, because of which we are returning 3. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to solve this problem, the first concept which we need to understand is how do we make a string a palindromic string. So let us first discuss the algorithm for this. So let us say the string which is given to us is AA. As we can see that the string is already a palindromic string, so we don't have to do over here. We can just return 0 in this case. Let's take another example. So let us say the string is AB. As you can see, this is not a palindromic string. Now, in order to make this string a palindromic string, we have two options available. The first option is to prefix this string with the last character, so BAB. And the second option is to suffix this string with the first character. So in such case, the string becomes ABA. And in both the cases, the string becomes a palindromic string. And this is the core idea which we are going to use in order to solve this problem. That is, we can make a string a palindromic string by prefixing the string with the first character, or we can make a string a palindromic string by suffixing the string with last character. Now let us apply this logic in order to make a 3-length string a palindromic string. So let us say in this case, the string which is given to us is A, B and A. As we can see, this is already a palindromic string, so we can just return 0 from here. Now let's take another example. Let us say the string which is given to us is A, B and C. Now, in order to make this string a palindromic string, we have two options available. The first option is to prefix this string with the last character. So let us prefix this string with the last character. In such case, the string becomes C, A, B and C. Or we can suffix this string with the first character. So this first character is this. So with this, as we can see, these two character matches and we can just remove these two characters. Similarly, these two characters matches, so we can remove these two characters as well. Now our job is to make AB a palindromic string. Now, in order to make AB a palindromic string, all we have to do is we can repeat the same process, which is to prefix the string with the last character. So let us prefix the string with the last character, or suffix the string with the starting character, which is this. Similarly over here, so CBC, and over here the prefix condition, which is BCP. Again, let us repeat the same process. These two character matches, so we can remove it. Similarly, these two characters, these characters and these characters matches, so we can remove all these characters. Now the remaining string length is 1, and as we know, all characters or all string of string length 1 is a palindromic string. So in this way, we were able to make a string a palindromic string. So if we follow this path, then the palindromic string which we are obtaining is B, C, A, B, C. If we follow this path, the palindromic string which we are obtaining is A, B, A and C, C. And similarly, we can find the palindromic string if we follow these two paths. But in all the cases over here, in all the cases, the number of characters which need to be added over here is 2. So 2 characters are what we are adding over here. So if you see this palindromic string, the 2 characters which we have added are these 2 characters. Similarly, if you see this palindromic string, the 2 characters which we have added are this character and this character. And in this way, with the addition of 2 characters, we are able to convert this string to a palindromic string, because of which we are going to return 2. So that's the general idea behind this problem. Now let us see how we will be able to solve this problem efficiently using dynamic programming. So let us say the string which is given to us is this. So let us say this is the string which is given to us. So in order to solve this problem, we need a DP table, a 2-dimensional DP table of size n by n, where n is equals to len of a string. So let's have a DP table of size n by n. So let us say this is our DP table and the initial value for all the cells is 0. Now let's take this string. So this is the string which we have. So the first thing which we are going to do is we are going to solve for all substring of size 2. So for instance, if this is the string, we will find out all the substring of size 2. So one such substring will be AA, another will be BB, another example is AB, and so on. So we will solve this problem for all such substring of size 2. So once we have solved all substring of size 2, then we are going to solve all the substring of size 3. In such case, the substring will be AAB, ABB, and so on. And continuing in this fashion, we will be able to solve the string of size n. So let us see how do we solve for all substring of size 2 and keep it in our DP table. So to begin with, we are going to start from AA string. Now in this AA string, we will compare the first and the last character. Since the first and last character matches, so this is already a palindromic string, because of which we are just going to put it as 0 over here. Next, we will move to the next substring of size 2, which is AB. So let us discuss for the case of AB. So as we have discussed earlier, in order to make this string a palindromic string, we can prefix this by the last character. So let us prefix this by the last character or suffix this by first character. In both the cases, we are able to make this string a palindromic string, and the number of extra characters we need is 1, because of which we are going to mark it as 1 over here. And where will be this entry? Well, the entry will be here because this is A and B. Similarly, the next substring of size 2 will be this substring, which is BB, and over here, since this is already a palindromic string, so we are going to mark it as 0. Then the next substring is BC, and this is not a palindromic string. And as we have discussed, in order to make this as a palindromic string, we just have to add one more character to it, because of which over here the size will be 1. Similarly, the next string is a palindromic string. So 0, then 1, 0, and then 1. And in this way, we have solved for all substring of size 2. Now let us look at the substring of size 3. So the first substring of size 3 is the first 3 characters, which is AAB. Now let us discuss about AAB. So let us say AAB is the string which is given to us. And this subproblem, if you see, the solution of this subproblem is stored in the DP table 0, 2. Let me just go up in order to demonstrate this. So this is my 0th entry and this is my second entry. And enclosing this, the substring obtained, which is AAB, we are trying to solve for that substring. Now let us see how we will be able to solve this. Now, since this is not a palindromic string, so we want to convert this to a palindromic string. So let us apply the same logic, which is to prefix this by the last character. So let us prefix this by the last character or suffix this by the first character. So after prefixing or suffixing, we can just remove these two characters. So this character is gone. Now we are left with a string of size 2. And this is something which we have already solved. So if we follow this path, then the minimum number of characters which need to be inserted in order to make this string will be 1 plus solution of AA. And please note, solution of AA is something which we have already solved. And if we follow this path, then the number of characters which need to be inserted in order to make this string a substring will be 1 plus solution of AB. Now let us look our DP table in order to find the solution of substring AA and solution of substring AB. So let us look at our DP table. So the solution of substring AA is this, which is 0, and the solution of substring AB is this, which is 1. So let us plug this value. So if we follow this, then this will be equals to 1 plus 0, which will be equals to 1. And if we follow this path, then this will be equals to 1 plus 1, which is equals to 2. And clearly, since we have to find the minimum number of insertion, so this is what we are going to choose, and this is what will be updated over here. So once we have solved for substring AAB, now let us solve for the other substring, which will be ABB. So let us solve for ABB. And this is which entry of DP table? Well, the entry we are talking about is 1 comma 3, which is this entry. So let us discuss the solution for this subproblem. So the subproblem we are looking at is AAB. Again, this is not a substring. So in order to make this a substring, we can prefix this by the last character. So let us prefix this by the last character or suffix this by the first character. So let us suffix this by the first character. Now after doing so, these two are gone and we are left with a substring of size 2. So again, this is equals to 1 since we have added one character plus solution of AA. Similarly, here also 1 plus solution of AB. And if we look at our DP table, this will be equals to 1 plus 0 and this will be equals to 1 plus 1. So over here we will get it as 1 and here we will get it as 2. And the minimum of these two is this value, which is 1. So this is what we are going to fill over here, which is this case will be 1. And following the same logic, we will be able to fill all these values. So all these values for the substring of size 3 will be 1. And in this way, we will be able to fill this entire table. And once we have filled up the entire table, whatever value will be over here, this is what we are going to return. And this will be our answer. So now let us formalize this. So let us say I want to fill up the entry of DP table DP of I comma j. Now in this case, first we are going to check whether stri string I equals to strj. If string I is equals to string j, so let me just take an example over here. So let's say AB and then some string, and over here CA is there. So as we can see, the ith character and the jth character of the string matches. So these two characters we have to exclude it and we have to check for this substring. So if this is my ith position and this is my jth position and I and jth values matches, then the next subproblem will be I plus 1 and j minus 1. And this is what we are going to use. So for this case, dp of I comma j will be equals to dp of I plus 1 and j minus 1. So let us discuss for the case where stri is not equals to strj. So let us discuss for that case. Let us say this is the sum string which we have. Now as we can see, these two character does not matches. So with this, I have two options, which is either I will prefix this string or I will suffix this string. So after prefixing this string, the string will be dcbabcd, and after suffixing this string, the string will look something like this. Now as we have discussed, these two characters can be strike off. Similarly, these two characters can be strike off. So please remember, this was our ith character and this was our jth character. So if we follow the path of prefix, then the next subproblem will be I comma j minus 1, and if we follow the path of suffix, then the next subproblem will be I plus 1, because now we have to check only this portion of this string. So I plus 1 and comma jth. So this is what we are going to do, and please note the minimum of these two. So this will be equals to one character since we need to insert one character plus minimum of dp I comma j minus 1 comma dp of I plus 1 comma j. And folks, this is the crux of our algorithm. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to form a palindrome and a string is given to us. So the first thing, let us take the length of a string in a variable n, and let us have a DP table of size n by n. So once we have this, let us go back to our DP table. So folks, as you can see over here, I was iterating the DP table in diagonal fashion. So our loop counter should be as such that we are able to iterate our DP table in diagonal fashion. So let us see how we will be able to do that. So for range of n, and then we will have our I, and I we are going to set it to 0. Then we'll have our j in range I to n. And this I comma j, if you see, this is essentially iterating DP table in diagonal fashion. Now once we have this, now we have to populate the entry of DP table. So as we have discussed, first we are going to check if string of I is equals to string of j. If these two are equal, then the DP table I comma j is DP of I plus 1 comma j minus 1. And if these are not equal, dp of I comma j is equals to 1 plus minimum of dp of I plus 1 comma j or dp of I comma j minus 1. And in this way we will be able to populate our dp table. Once we have populated our dp table, all we have to do is we have to return dp of 0 comma n minus 1. And that's the pseudocode for this problem, folks. So that's the pseudocode of this problem, folks. Now let us see how we have implemented this in Python and C++. So first let us discuss the Python implementation. We have n, which is the length of the string, and a DP table of size n by n. Then we are iterating the DP table diagonally, and then we are checking whether ith and jth characters are equal. If they are equals, then the DP table will be updated in this fashion. Otherwise, the DB table will be updated in this fashion. And then we have to increase our I in order to iterate DP table in diagonal fashion. And towards the end, we can return DP of 0 comma n minus 1. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at our C++ implementation. So the C++ implementation is also the same, folks. Over here, n equals to length of the string. And then we have a DP table of size n by n. And we are iterating DP table in diagonal fashion. If ith and jth character of the string matches, then in such case DP table will be updated in this way. Otherwise, DP table will be updated in this fashion. And towards the end, we can return DP of 0 comma n minus 1, which contains the minimum number of characters which need to be inserted in order to make a string palindromic string. Now let us submit our C++ solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.